everybody please stand and welcome the entering class of PhD students into the Case Western Reserve University School of Medicine. Be seated. Thanks. Good afternoon, students, faculty, parents, family, and friends. Welcome to Seeds of Discovery, the inaugural PhD White Lab Coat ceremony at Case Western Reserve University School of Medicine. I am Paul McDonald, the Associate Dean for Graduate Education in the School of Medicine, and I am just thrilled to have all of you here with us today. The purpose of this ceremony is to formally recognize and celebrate this entering class of PhD graduate students. Just as important, it is also to welcome you as our junior colleagues into the research profession. Webster defines profession as a calling requiring specialized knowledge and often long and intensive academic preparation. I think it's reasonably safe to say that we all get the long and intensive academic preparation part of this definition by Webster. I want to focus just a bit on the calling part. You have all been called at some level to this profession and to Case Western Reserve University. Perhaps that biochemistry class during your junior year stimulated an early interest in how cells obtain, store, and utilize energy. Maybe that materials course sparked a fascination for understanding drug delivery vehicles or regenerative implants. Your undergraduate and summer research experiences in state-of-the-art labs across the country likely ignited those early flames. They drove your early passions for research and uncovering new insights into complex biological processes. So, your undergraduate experiences have called you to this profession. Your dedication, your work ethic, your sacrifices in those early years have resulted in your admission to our PhD programs here in the School of Medicine. And now that you are here, you will continue to sacrifice, work hard, and study intensively. But it is incumbent upon us, the faculty and the administration, to nurture these early seeds of curiosity and excitement, to allow them to sprout by providing cutting-edge educational experiences, research training, and sound mentoring, and to promote the growth and development of these seedlings into mature research scientists by providing the professional skills and leadership experiences needed in today's research enterprise system. And so we are here to celebrate you and the beginning of your journey into this profession and to this calling. This is an exciting moment for me and for the School of Medicine. This represents one of the first times, I think, in modern history of the School of Medicine that all entering PhD students in our programs are together as a single group in a single room for a single event. It doesn't happen very often. Even at graduation, it's unlikely that you will see many of your colleagues that are in this room right now. The nature of the PhD degree and the variability of research projects means that you will be leaving the School of Medicine at different times and stochastically moving on to the next steps in your professional development. Importantly, we are here together now to celebrate this group of PhD students, a truly international, diverse, and accomplished collection of young scholars. There are a total of 72 students entering our PhD programs this year, 60 PhD students and 12 from the Medical Scientist Training Program, or the dual MD-PhD degree track. These 12 students are currently entering their third year, or the PhD phase of their training program. Of these 72 students, 57% are female, 41% are male. They represent 11 different countries, including China, India, Iran, Lebanon, Ecuador, the Netherlands, Colombia, Korea, the US, and Puerto Rico. 48 of you come from over 20 different states, including California, Colorado, Minnesota, Massachusetts, Florida, Connecticut, South Carolina, and Tennessee, to name a few. 36% are from the great state of Ohio. And 8 of them, or 11%, being from our nationally recognized undergraduate institution here at Case. You come to us from other highly prestigious institutions, including Johns Hopkins, Boston University, Washington University, Yale, UCLA, and Pitt. I won't mention the University of Michigan. The richness and diversity of this, no insult intended. The richness and diversity of this group of entering PhD students will add tremendous value to the intellectual environment here in the School of Medicine, and we are all looking forward to reaping that harvest. The unique, multicultural, and rich scholarly atmosphere at Case is a direct result of the leaders of this institution and their forward-thinking approaches. I want to specifically welcome and thank the CWRU administration that is attending today and for supporting the Seeds of Discovery effort. These include Deputy Provost of Case Western Reserve University, Dr. Lynn Singer, Vice President for Inclusion, Diversity, and Equal Opportunity, Dr. Marilyn Mobley, Dean of the School of Medicine, Dr. Pam Davis, and Vice Dean for Research at the School of Medicine, Dr. Mark Chance. I want to welcome the faculty that are in attendance today. Your dedication, mentorship, enthusiasm, and passion for research are key ingredients nurturing these young scientists and are instrumental for their continued growth and development. I also want to recognize and welcome the chairs and the graduate program directors that have sacrificed their time to come spend this moment with you guys and gals. It's just a real pleasure to see them involved and seated with you in this ceremony. Finally, I wanted to take a moment to welcome and recognize the parents, family members, partners, and friends that are here with us today, as well as those that were unable to attend. We have approximately 80 guests in attendance today, some traveling from as far away as Boston, Chicago, Puerto Rico, and Texas. We got to know them a little better at the visitor lunch this afternoon, and they also heard from several BGSO or Biomedical Graduate Student Organization students about the joys and setbacks we all experience in the PhD thesis research. These students would not be here without your continual, lifelong support, encouragement, and love. Life provides us with a stream of joys and sorrows, successes and failures, blessings and calamities. The love and support that family and friends provide is the rudder that keeps us upright, afloat, and moving steadily through that stream. Would all the parents, family members, partners, and friends of the students please stand up and be recognized by us all. Again, just a final welcome to everyone attending this ceremony. I wish you all a grand, rewarding, and memorable experience today, and I hope you're all still in the correct order. It looked a little confusing, so you better check your seating charts. Okay, it is a great pleasure for me to introduce Dean Pamela Davis as today's keynote speaker for Seeds of Discovery. Dr. Davis received her BS in chemistry from Smith College and her PhD in physiology and pharmacology and her MD both from Duke University. She moved to Case Western Reserve University in the early 80s to direct the Cystic Fibrosis Research Center and pursued research interests on cystic fibrosis lung disease. She was the chief of pediatric pulmonary division of Rainbow Babies and Children's Hospital for over 20 years. Dean Davis has published more than 130 original articles, mostly in the area of cystic fibrosis. She holds 7 U.S. patents and is a founding scientist of Copernicus Therapeutics. She has been funded continuously by the NIH for over 30 years, most recently as the principal investigator of the multi-million-dollar Clinical and Translational Science Award to Case Western Reserve University. She has served on numerous local and national advisory boards and won a multitude of awards, including the Paul DeSantis Award from the Cystic Fibrosis Foundation, the Rosenthal Prize for Academic Pediatrics, and she was inducted into the Cleveland Medical Hall of Fame and the Ohio Women's Hall of Fame. Dr. Davis was named Dean of the School of Medicine at Case Western Reserve University and Vice President for Medical Affairs in 2007. And I want to welcome Dean Davis to give the keynote speech.
Well, I'm delighted to be here this afternoon, and thank you very much for joining us. I am proud to be witness to the first and hopefully the start of an annual series of Seeds of Discovery PhD White Lab Coat ceremonies. Your future as scientists and researchers is bright with opportunity. What you learn over the next few years and what you discover over your lifetime will be integral to the advancement of medicine. You will have the chance to create that initial discovery that leads to new understandings of physiology, human biology, and disease, and perhaps suggests the next cure. Now, some of you will move seamlessly from the lab to the hospital, interacting with patients and being inspired by their stories. But even if you never meet a patient, or even if patients never learn your name or the names of those whose research made their treatments or recoveries possible, your incredible achievements will still influence their lives in major ways. Now, I come from a field that has just reaped the benefits of hundreds of investigators working together. I come from the field of cystic fibrosis. When I joined the field of cystic fibrosis, the life expectancy was 11 years. Now, it's about 42 years at Rainbow Babies and Children's Hospital, and we stand on the verge of curative therapies for at least some genotypes of CF. Hundreds of investigators work together to discover the gene for cystic fibrosis, use this gene in the laboratory, in cells, and in mice to define its function and to determine how it goes awry in the disease, to create the cell lines to use in high-throughput screening procedures to discover compounds that improve the abnormal function of these mutant forms of the protein, and then to modify the initial compounds discovered to optimize their drug properties, and finally to test these drugs in animals and then in man. The first drug with potentially curative properties for a small subset of patients with cystic fibrosis was released by the FDA in February of 2012. This pathway was long and tortuous. It took 22 years from the discovery of the CF gene to that point. It took geneticists, physiologists, pharmacologists, biochemists, structural biologists, animal models expert, clinical scientists, and of course, the patient volunteers, finally, to crack this disease. But crack it we did, and it all began with fundamental discoveries, like those you're going to go after in the laboratories in which you work. Now, at CWRU, we ask you to think beyond the possible. So I want you to consider what that really means at your stage of the education. It's more than a motto. It's the standard to which we aspire every day. Now, as students, we sometimes focus on competing for grades or cramming for exams, and as undergraduates, we expected our teachers to distill information into easily digestible bits and spoon-feed it to us. This ceremony marks you as moving beyond that point. Now you will be treated less as a passive learner and more like a colleague, responsible for your own education, driven by self-motivated learning and a passion for understanding. Don't think about this program simply as a continuation of your earlier learning or your earlier degree. Consider it a means for you to foster your own intellectual curiosity, your scholarship, and your critical thinking. Here you'll learn how to become your own teacher, directing your own paths and deciding what you want to pursue. Now, your colleagues and your mentors will be guides and partners, but you must become the driving force behind your own educational development. Your ideas and discoveries won't just impact the future, they are the future. You will discover knowledge nobody else has known before. Sometimes these discoveries will be the result of serendipity and being an acute observer, as Alexander Fleming did when he identified the penicillium mold in 1928 by observing a contaminated culture in an completely unrelated study. On the other hand, sometimes your discoveries will be the result of years of meticulous research and study, like Isaac Newton, when he developed the foundations of calculus through decades of working out the details of new and significant systems of mathematics. And they influenced mathematics far, far into the future. So whether fortuitous or whether planned and pursued, these are the actions of people who think beyond the possible and change the world. I'd like you to get up every morning expecting to change the world. Now, you won't be working alone. Modern scientific research is a process of collaboration and partnership. Your new peers will expect you to think and act with professionalism and with enthusiasm. They will expect you not to limit yourself to a single model. Huge advancements have been made when people of all disciplines come together to work on a problem. What might you accomplish by working with experts in engineering, statistics, mathematics, or the social sciences? What can you learn from your colleagues in history or art that might generate bold new advances in your own field? In my field of cystic fibrosis, collaboration has been essential to success and progress. Initially, in the days way before GWASs and deep sequencing, finding the CF gene was really a daunting problem. Indeed, it was, depending on how you want to count it, either the first or the second gene whose position was identified and discovered with absolutely no knowledge of the function of that gene. It was, and that was done by positional cloning. To do so, the army of CF physicians over the United States and Canada, caring for CF patients, collected DNA from every family that had more than one sibling affected by cystic fibrosis and contributed to the cause to accelerate the process. It took that rich source to allow 3 different labs to come together to discover the gene. Francis Collins and his first graduate student, Mitch Drum, now a professor here, in Michigan by gene jumping, Lapchi Choi in Toronto by fine sequencing, and Jack Reardon in Toronto for the cell models whose function was corrected by transfection of the putative gene. Not one of those people could have done this alone. It's not only scientific collaborators that are essential for the success of you as graduate students. Parents, family, and friends are essential to sustain you when that delayed gratification that you thought you accepted when you started the research project now seems to be forever, or when a cherished hypothesis fails, or when things go terribly wrong in the lab and your mice escape, and you have to step back and regroup, or even when you have to work long hours to complete your experiments. The role of the families and friends is not always easy. Graduate study in biomedical research requires enormous time and dedication that can take a toll on family and friends. But I assure you that the encouragement and support of your family and friends has been and will continue to be an important component in the achievements of our brilliant young new graduate students. Therefore, those of you who are about to embark on the graduate student adventure, be sure to thank those people who love and support you. Thank them, as they say, early and often, and thank them sincerely. Without them to turn to, your road would be much more difficult and your successes would be a lot less sweet. Remember, too, that your position is now assuming some great responsibility. Your chosen profession demands absolute integrity. For science is critical in advancing human health, and it needs to seek the truth. In a moral sense, and in a very tangible sense, in that your education and your research are now funded by society, you owe society your very best, both intellectually and in terms of integrity and accuracy. You have a duty to strive for excellence, not only for yourself, but also for the people and foundations that trust you to discover important advances and make the best use of their support. You have a responsibility to be the best that you can be. You have the responsibility to hone your mind in the best way possible, and here you will have an opportunity to learn and explore. Make the most of it. Accept the help of your peers and mentors, and embrace the chance to control your own learning. Now, American physicist Joseph Henry once noted that the seeds of great discoveries are constantly floating around us, but they only take root in minds well prepared to receive them. Your education here at Case Western Reserve is designed to propel you forward so that you can capture and nurture those seeds. It's okay if you don't always know what to do with them once you have them. For most of us, the path to discovery and the pathway and the journey is part of the fun and the part of the excitement. Just wait and see what amazing things will grow from those little seeds and those sparks of ideas. Once again, I'm truly honored to welcome you to the start of a wonderful adventure. It will have great joys as well as great responsibilities. But in taking this white lab coat today, you proclaim to the world that you are ready to face whatever is approaching with an open mind and a willing spirit. Thank you very much, and good luck to you all.
Okay, we would like to begin with the awarding of the coats, and we're going to lead off with the Department of Biochemistry. And those of you that got out of order, try your best to get back in order.
Either that or love the coat to death.
I'm Dr. Martin Snyder, representing the Department of Biochemistry. I'll be wearing a different hat in just a second. In biochemistry, our concern is with the structure and function of biological molecules. So we study proteins, lipids, and nucleic acids with particular emphasis on their roles in mammalian biology and human diseases, including diabetes and arthritis and cancer and other diseases. It's a pleasure for me to welcome our new students into our community of scholars as colleagues. You have a great responsibility that you've heard others talk about, but in biochemistry you have another responsibility. Every year we have a student-faculty softball game, and the students have not won in living memory, so that's we'll add that to your challenge as well. So let me introduce our students to you. The first is Molly Hannigan, and she comes to us from the University at Buffalo. Next is Maya Nguyen from the American University and from Georgetown University. And last is Jen Song from Liaoning Normal University. So I'm now going to change hats. I'm also the director of the Biomedical Sciences Training Program. This is Dr. Robert Peterson, who's the academic advisor for that program. We're not, strictly speaking, a PhD program. Rather, we're a consortium of 11 different programs. And so we admit a large class. We're the largest PhD program in the school. And over the course of this year, our students will travel through over 200 laboratories as they seek out their PhD advisors, and then they'll choose not only their advisors, but to do their degrees in neuroscience or nutrition or biochemistry or one of the other programs that you'll see represented here today. And it's my pleasure to introduce our class of 21 students. They come from 10 states, Puerto Rico, and two countries. And they're all good-looking, studious, and very highly qualified. Let's start with Valerie Adorno Cruz. She comes from the University of Puerto Rico at Mayagüez. Next is Elizabeth Akinbiyi. She comes to us from the University of New Haven. Next is Michal Bonar from McGill University. Next is Emily Deutschman from the University at Buffalo. Lauren Donovan from Cal State Fullerton. Will Nelly Hernandez Sanchez, also from the University of Puerto Rico at Mayagüez. Kendall Hoover from Boston University. Clifford Ivester from the University of Dayton. Mary Kemmerer from Clarion University of Pennsylvania and Case Western Reserve University. Matthew Nahr from Lock Haven University of Pennsylvania. Nha Le from Ho Chi Minh University of Science in Vietnam. Joshua Miller from DePauw, not DePaul, University. Justine No from Case Western Reserve. Caitlin O'Connor from St. Mary's University of Minnesota. Abby Pearl from Lehigh University. Laura Rojas Coy from the Universidad de los Andes in Colombia. Lucas Serdar from The Ohio State University. Ann Smolko from Lehigh University. Colin Venner From Denison University, Jeremy Whitson from Muskingum University. And finishing up our class is Jacob Wasotsky from the University of Alabama at Huntsville.
Good afternoon. I'm Bob Kirsch. I'm the Interim Chair of Biomedical Engineering. I'm joined on the stage here by Dr. Sheen Yu, who's the Associate Chair for Graduate Studies in Biomedical Engineering. Biomedical engineers use principles of engineering, such as design and analysis, to solve problems and make basic discoveries in biology and in medicine. So I'd like to welcome our class, our incoming class. First of all, Nadia Ayat from Case Western Reserve University. Next is Natalie Cole from Case Western Reserve University. Next is Annika Frankenmulder from the Delft University of Technology. Emily Grosick from the University of South Carolina. Christopher Hernandez from Boston University. Deshaun Hickman from Yale University. Pratik Prasanna from Calicut University and Rutgers University. Oh, sorry, I skipped one. Wei-Ching Lo from National Taiwan University. Alice Yang from Case Western Reserve University. Thank you.
where it gets interesting, I think.
Hello, I'm Jiayan San, Professor of Biostatistics, representing the Chair of the Department of Epidemiology and Biostatistics, distinguished University Professor Robert Elston. Together with me is Suda Younger, Professor of Genetic Epidemiology, representing the Graduate Program Director of the department. The core disciplines of epidemiology and biostatistics correspond to 5 PhD concentrations. So we are really multidisciplinary department. And the first concentration is in genetic epidemiology and bioinformatics. The next is global health epidemiology, health behavior and prevention, healthcare organization, outcomes and policy, very long, so we call it HCOOP. And finally, the new modern biostatistics. This year, we have 10 new PhD students with the following 4 wonderful representatives, whom I'm going to call to receive their white coats. The first, Haley Gitterman. Oberlin College and Rutgers University. Jan Ik Chell, Korea University, Korea, and Harvard University. Heather Voss Hoynes, Case Western Reserve University. Han San, Lancaster University, China, and the University of South Carolina. Okay, so that's all our representatives here. And there's a wish by Robert Elston. And he welcomes all the graduate students. He thinks our graduate students should work as a team player and work for the common good of the entire School of Medicine. That's all from the department.
Hello, I'm Tony Winshaw-Boris. I'm the chair of the Department of Genetics and Genome Sciences. And I'm proud to say on this occasion, I'm also a recent graduate of Case Western Reserve University, having obtained my PhD in 1984 and my MD in 1987. So welcome to the community. And I'm joined by Ann Matthews, our Director of Graduate Studies. We have one student to introduce, an MD PhD student, Matthew Elett, who's from Washington University in St. Louis. Matthew? And I should tell you just a few things about genetics and genome sciences, although I'm sure all of you know something about genetics since it's in the news all the time. So genetics is the inheritance of traits, either from single genes or a number of different genes. And genome sciences is the study of all the genes in the genome. And our department does all those different sorts of studies in model organisms through humans, because we also have a clinical component of our department as well. So thank you very much.
Hello, I'm Paul DiCorletto. I'm chair of the Department of Molecular Medicine, and with me on the stage is Dr. Jonathan Smith, who's our graduate program training director. Our molecular medicine PhD program integrates medical knowledge into graduate training. The goal of the program is to train research scientists in a way that they'll be effective members of multidisciplinary teams pursuing various aspects of medical research. The thesis projects of our students represent areas of basic and applied research that are relevant to human health and can lead to new understanding of the causes, diagnosis, and treatment of diseases. I'm going to introduce you to our illustrious class this year. First is Karayum Ayasufi from Case Western Reserve University. I'm glad he has the job of putting on the lab coats. Next is Courtney Hirschberger from the University of Mount Union. Next is Anthony Gramovsky from Ohio State University. Jessica Sachs from the University of Southern California. Rita Tomei from the American University of Beirut. Cynthia Alicia Trauber from Oakwood University. And finally, Stephen Walker from the University of Alabama at Birmingham.
Good afternoon. I'm Henry Brungraber, Chair of the Department of Nutrition, and I am joined by Colleen Croniger, Graduate Student Officer. Nutritional research groups a number of disciplines to investigate the regulation of metabolic pathways in health and disease. Our department runs the Mouse Metabolic Center and the Case Center for Metabolomics and Isotopomics. And I'm delighted to be the advisor of Kirkland Wilson, who received his undergraduate, come Kirkland, who received his undergraduate degree in chemistry biology from North Carolina Central University.
Good afternoon. I'm Alan Tartikoff, professor of pathology. I'm standing in for our chair, Cliff Harding, and it's a pleasure to be with you at a moment which is a turning point for so many. I'm joined by Dr. Robert Peterson, who is the director of our graduate program in pathology. Pathology is an ambitious discipline, far-reaching, with a history which is, believe it, much too much to encompass in a few words. We have, of course, several tracks of specialization in neurodegenerative disease, cancer, immunology, and others. But more than that, pathology is known as an interface between clinical concerns and the bench. It is a locus for deep thinking, intellectual endeavor. The frontier is very broad. So it's with pleasure I'd like to welcome our 6 students this year. Our first is Brian Benson, if I dare say, from the University of Michigan. Congratulations. Next, Anna Henry, coming safely from the University of Dayton. Congratulations. And now we have Alexandra McMillan coming from one of those hotbeds of the history of pathology in the United States, Johns Hopkins University. We have Gloria Tavera coming from the University of Florida. Congratulations. Alexander Tong coming from Rhodes College. Congratulations. And finally, concluding the challenge, Grant Zimmerman from the University of Illinois in Champaign. Congratulations. Thank you.
My name is Chris Palczewski. I'm chair of pharmacology, and with me is Professor John Neal, who is our graduate program director. And today we welcome 2 students to our body and hopefully more from a BSTP program. So pharmacology is branch of medicine and biology, and logia is related to knowledge and understanding. And of course, pharmacon means, that depends how long we go back. It really means poison. But in modern language, it means drugs. So,
Thank you.
Really how the drug interacts with our body is very important because it allows us to invent new ways of treating inherited and acquired diseases, and that's really what we're working on. And it's really a very exciting time right now because it also spans all of the other branches of medicine to identify cures for many of the diseases. So with that, I would like to welcome Ryan Clinton, I know Bill Clinton is somewhere there, very anxious. From Worcester Polytechnic Institute. And Dioye Tanate from Indiana University. And clearly John doesn't help his wife how to wear
Good afternoon. My name is Walter Boren. I'm the chair of the Department of Physiology and Biophysics, and I'm joined by Witold Sorevich, who's our director of the PhD program. Physiology in the Chinese language is represented by three symbols, which represent quite literally the study of the philosophy of life, and we're interested in understanding how the body works, starting at the level of molecules up through cells, tissues, whole organs, and the entire organism. Biophysics is the application of physical principles to biology and can be divided into two major halves, cellular biophysics, in which we apply optical and electrical techniques to study how cells and molecules work, and also molecular biophysics to use technology such as protein crystallography or electron spin resonance, for example, to study how proteins fold and what their structure is. And this year we welcome 6 students to our PhD program. The first is Peyvand Amini. Welcome. The second is Sahil Gulati. We also welcome Chia Li. David Litvin. Pamela Marcotte. And Meng Yuan Xu.
Good afternoon. I'm Dr. Mark Chance. I'm director for the Center of Proteomics and Bioinformatics, and I'm here to introduce our last program, but our newest. Systems biology and bioinformatics is the study of big data and the coupling of computational and experimental methods to understand structure and function of proteins, nucleic acids, and cells. We have 3 entering students this year, 2 of which are here with us today. The first is Doug Brubaker from Case Western Reserve University. Our second is Danica Wirija from University of California, Los Angeles. So we see that the rack is empty. That's a good thing. And I see you all have your beautiful white lab coats. You look great. Congratulations to you all. So Dr. McDonald said it's unusual to have you all together at one time, perhaps unprecedented, and you will start to drift out into your courses and your departments and your labs and drill down and differentiate yourselves. But I'm here to tell you that you are one group. You belong to one school of medicine in one university. And that school of medicine has a long history and a rich tradition, and it has values of excellence in education. It has values of building community research programs. It has values of basic science discovery to ultimately benefit patients. Now, I'm privileged to have the opportunity to work with many great leaders in this school. Dean Davis, Dr. McDonald, all the basic science chairs who are here today, all the basic science program directors who are here today. I'm honored to call them my colleagues. They are the current leaders, but your white coats mark a change where you are now their new colleagues. You are now their partners in discovery going forward. Today, you are the new leaders of the School of Medicine of Case Western Reserve University. I want to thank all the family members, partners, friends who are here, who are showing their support. I want to thank Dr. McDonald and the staff in the graduate office for organizing this event. And we will have the white coats process out, and then we will have a reception. And I thank you all, and I congratulate you all again.